we're going to talk about SDR Rover kit. That is, I believe, to be next generation because we managed to do 8 bands and 8 grid in ARL June and September contest, well, actually in a September contest, within a very small size constraint. And well, you will see the picture in one moment, but I'm just saying that this is something really mind-blowing. We are downsizing everything. We are also making this very affordable by downsizing it. The entire set costs only about $400. Well, with an extra piece of hardware, it shouldn't exceed $450. So it can be some student project, and I mean, it's totally doable, even for high school students. So yes, just in case. I know some club has like youth outreach sessions. And if that is the case for RATPAC, I mean, here's probably a good project idea for you too. But anyway, let me introduce myself a little bit. So this is Hisen, KD2 TAI, officially known as Zhang. Nobody really use that. So just call me Hisen. Think of Heisenberg, so Hisen for short. I'm currently pursuing a bachelor degree in computer system, dual computer system engineering. That's a long name. Essentially, what it says is software and hardware, and perhaps RF too. And my concentration is on digital communication and AI technologies. I'm the current president of WTSZ Amateur Radio Club at RPI. I was first licensed here in the US shortly after I got admitted to RPI, and I upgraded my license earlier this year to be an extra. And before we really start, I want to talk a little bit about WTSZ. It's probably one of the earliest ham radio club in this country. So ever since 1911, I believe there were about 4 clubs that were doing amateur, not just amateur radio, but experimental radio stuff back then. And in the early 1920s, they were merged into one club. There are a lot of story going on here, but back in the old days, W2SN was a very outstanding club, especially in early history of radio exploration. We do a lot of activities, and actually this project is sort of, well, even though I did most part, it's sort of club activities too. We do a lot of activities, we do a lot of projects for the club, and also we have research and publications that's built upon that. We have a article that was recently published. It's on QEX in the next coming issue. I believe it's January and February. There is one article about using an AI-powered transcription boat for FM transmission. It's available there. If you have access to QEX, just go there. If you don't, I do have a copy. Just email me, ping me with the email, and I'll send you a copy of that. And just saying, we are doing quite a lot of things here at WTSZ, and here's one possibility of the project we're doing. So, roaming summary. I assume most people here understand what amateur radio is, and of course, amateur radio contest. But generally speaking, a station that seek to contact as many other amateur radio club as possible in a given period of time, and exchange the information required. Usually, it's the grid. Sometimes it's the sequential number. I mean, rules differs, but generally speaking, if you make more contacts, that gives you a higher score. So one rule that allows you to make more contacts by relocating your grid in the Maidenhead system is doing roving, which means that you will drive around with your portable radio to perhaps to nearby grids and start communication with other stations. In the especially this is especially helpful in VHF UHF radio contest. As I said, we did this in September VHF and UHF contest. Because HF you don't really care, it's long range, it's omnidirectional, but VHF and the UHF, especially the microwave band, that is just not the case. So you have to do a lot of site surveying first and make sure there's a line of sight between your place, the place that you're gonna go, and the other station. So in this case, the W2SZ is doing this as a team. We have basically covering, we have the coverage map here that basically covers most of the New York and northeastern states, Vermont, New Hampshire, I believe. Yes, Massachusetts, most of it. And it's really a teamwork. And I'm KD2 TEI, so you can see I'm doing this like I planned to get 9 grids, but one of them was actually closed after sunset, so I couldn't really get to your FN43. Believe me, that was a long time. That was very long driving. I did it in 2 days. The first day I sort of did the 6 square from FN21 to FN33. On the second day, I did further, like more remote grids. That's FN34, 43, and 42. Basically, just expect 50% of time that you will spend on road. The goal for me is technically make contact with our main station on Mountain Greylock. That is the West Massachusetts on the FN32. In this case, we have I just go to a site that we already surveyed and make sure there's a line of sight, so I can always reach the main station with fairly low level of power. So here's a roving summary for me, generated by a script that I did. So just to confirm, it's 8 bands and then 8 grids. That was a significant contribution to the team. Basically, we are doing this without considering multipliers. But if you do take multipliers into account, then the team contribution will be around 17%, but otherwise it's 10%. Remember, it's just from one person. And think about that. If we have multiple people doing roving with this new kind of kit, the total score will be just insanely high in this case. So roaming setup. Before we really show the picture, I want to talk about design goals here. Because the conventional roving kit is usually made of 2-meter radio, a bunch of transmitters, power amplifiers. It's a really complicated set. And because you only use it twice a year, it's very likely you'll find it broken in the field, which is not good. So we are trying to solve this problem by cutting down parts. I mean, if we can share multiple bands on one set of equipment, that would be great. And that is just the nature of SDR, the software-defined radio, because it's wideband. Most of the equipment that you can find off the shelf can do typically, well, from a few megahertz all the way up to a few gig. So for a very reasonable price, right? So this is what we are doing. We're trying to simplify things by doing one part fits all, or we're trying to do something wideband in this radio context, implying that we only need minimum number of parts for this. So we have our philosophy pinned down. KISS, keep it simple and stupid, and it should be wideband, which means one part fits all. And it should allow quick deployment because we want everything to be efficient. And finally, the setup should be compact. Everything should fit in a backpack. And as I would mention, while this is not intended, a side benefit of doing that is the kit is actually very affordable. We also have a bill of materials section in this presentation that you can check. This is what we used to have, Rover kit. So we have 1-2 meter radio and bunch of transverters times number of bands that you want to operate. Well, let's say in this case, if you see the little knob there, it tells you what it does. It can do from 144 all the way up to 24 gig. But usually we just do it up to 10 because 24 gig really depends on weather a lot. But you know, think about that, how many bands there are in the rack, right? And you have to get the right power amplifier for each bands too. So that's extra weight, extra power consumption, and a bunch of relays and tripod antenna. That's just something you couldn't avoid. But this was the old kit, the W2AAU used. W2AAU is my album. This is the new setup, much smaller as you can see on the picture. You'll just need a clipboard and a laptop, and perhaps a bin that carries all the accessories too, but that's pretty much it. Optionally, you can have a battery and inverter, which means that you don't really have to use a noisy generator, which means extra weight and the gasoline. Just make the setup a bit more flammable if you want, but in this case, you could avoid it. And also the filters, it will be nice to have filters because it definitely improves your SNR and it prevents you from interfering with others because we're operating at a very low power, in this case sub watt, usually a few hundred milliwatts, and that is something totally acceptable even you have, say, fair amount of leak in harmonics. So here's a gallery. That's what we did in the field operation. So it will be nice if we have ad hoc feeds, but in this case, I'm just using a periodic Yagi, and use the dish as a reflector, which is sort of hard because you have to find the right focus so that the beam is correctly shaped and pointed at where you want to go. But it's totally doable. That's one improvement we can do next time. As you can see, the entire setup is pretty small and compact as I promised. So here's system block diagram. SDR, I understand that not everybody, I mean, you probably heard about it, but not everybody understand what like software-defined radio is, the concept behind the scene. But basically, instead of using a mixer and a local oscillator to down convert your band to your IF, the SDR does analog to digital converting directly, sometimes with a mixing stage too, but in this case, just to simplify things a little bit, we assume that we just directly sample from the RF tuner so that we have all the sample digitally ready and sent to digital signal processor. In this case, it's my PC, my laptop doing the job. So here is the full system diagram containing hardware, software, and a bunch of filters and dish and feed if you would like to include. Basically, the software are running on my laptop, interfacing with the hardware using USB for data and a serial port to do the TR switching. Basically, it's a little script that's running on my laptop that send the command over a serial port to microcontroller, telling the relay whether to switch to transmit state or the receiving state. Let's zoom in a little bit. So here's a closer look at the kit or the clipboard. It's just a smart way that I can mount it without leaving, the tape residuals everywhere. So it's sort of cool. As you can see, the board is pretty clear. On the top half of it, you will see the control circuit and relays. Down there, you will see the TR switch. And on the right-hand side of TR switch, it is the common RF that is going to the filter banks. And on the left side of TR switch, I don't know if there's a laser pointer or something I can use, but if you can identify this. There are two ways. One way that's RX path that's going directly into the Pluto SDR. The TX path actually use a low noise amplifier as a power amplifier. It doesn't matter because we are doing this at very, very low power level. So yes, this LNA, I believe $3 LNA actually works pretty well for the job. And this is exactly the same thing, except it's an abstract diagram that you see here. We have the Pluto SDR that we are using one set of TX and RX ports. We have the LNA, the low noise amplifier, as a power amplifier on the TX path, which is controlled by relay, which is controlled by microcontroller, which receives the command from my laptop. And after the signal is being amplified, it reaches about 100 milliwatts, about 20 dBm, and it shares the path with RX separated by a TR switch in this case. That's pretty much the hardware side of it. And as you can see, it's very, very straightforward. Nothing else really. On the software side, it's a bit more complicated. And I'll dive into some of these blocks later, especially the SDRangel. It's just a very interesting piece of software with very, very well-designed structure, but it takes some time to learn how things actually work with SDRangel. So the SDRangel, together with Pluto SDR, function as a radio, the radio that you see on the desktop. The way that you interact with the radio, I mean, instead of just turning the knobs, in this case, it's fully automatic, which means that there is a little script that I did in the background that send me directly to the frequency and the mode that I want to make contact with the main station. This is done by HTTP API. There's a RESTful API that's running in the SDRangel that if you have a client, you can make a request over the network. In this case, you don't have to connect to the internet. It's just if I would like to make an analogy, it will be the COM port. But nobody uses COM port nowadays. It's just network is more standardized. It's universal on every single operating system. So, COM is just outdated. We don't use that anymore. So here's SDRangel. For the signal inputs, well, there are numerous things that you can put in, right? It's just a microphone or key. That's very common. You can also have digital mode too by using virtual audio cable, like VB cable or anything else at your option. So that's pretty much the software side, except we have to know if there's any activity in the virtual audio cable so that we can turn the TR switch. We can toggle the TR switch. And this is done by using a module called PyAudio. This little script, PTT Vox script, is written in Python, and we are using PyAudio to monitor the audio cable, the virtual audio cable level. So when there's signal coming, we will turn the we will turn the TR switch to the transmitting mode. And when there's no activity, we just put it back in the receiving mode. It's pretty much like box. So, and lastly, filters. We have a bunch of filters. We are doing this for 8 bands, all the way from 144, 222, 432, 902, 1296. I couldn't recall the number now because I haven't done that in a while. I did this back in September. I just had a bad memory. But we have 8 filters, which is connected to the hardware, the common antenna ports, using SMB connectors. I don't know if you guys ever seen SMB. SMA is pretty familiar to you, I believe. SMB is a snap-on version of SMA. So you don't have to deal with that thread. You don't have to screw and unscrew it. It's really just snap. So think of BNC, right? But BNC technically only goes up to 1 gig, but SMB does much higher than that. So that's our option here. Without SMB, we will do relays, which is actually fully automatic. But given that it is very hard to find 8-way relays, not to say they're expensive, but you can rarely find any surplus that's of that specification. And also you have to do a lot more programming, and you have to take consideration that most of these relay operate on 28 volt, which means that you will have extra power supply, which I definitely do not want to introduce because of philosophy. Remember, keep it simple. So everything on this system is powered on 5 volt. It's USB voltage. So just get a good USB cable, and you are able to power everything from your laptop, a USB port. So here's bill of material. As you can see, everything sums. Actually, it's slightly under 400, but I did not include some, well, let's say the cost of using breadboard or something else because I already have them. But if you would like to create everything brand new, then I think $450 will be a good estimate for it. And mostly, I'll say like 90 or 80% of the cost is SDR, and you can definitely use that SDR for other purposes. That's why I don't want to leave like glue on the shelf. That's why I just fix everything using bungee cord, because I can always reuse it for other purposes. And actually I do. So the software, the SDRangel, as I promised, I'm going to explain how this SDR software works. You probably heard about HD SDR on Windows, SDR Uno if you're using SDR Play system. SDRangel is a open source software, which means that it's free and you get the source and you can adapt it if you want. I'm just living fine with it. So, but SDRangel is highly configurable. It's nothing like any of those software that I just mentioned. So think about this. You will have a source and you can have multiple channels attached to it. Well, in this case, it can be FM demodulator, SSB demodulator, ADSB, that's for airplane tracking, and many, many others like SSTV or ATV or, well, I mean, you name it, it's SDR, so you can just add arbitrary channels that you would like to, like page decoder, stuff like that. You can have multiple of them running all together simultaneously. And you will hook all of them to the source, which is your SDR receiver. Right, that is cool because it does not have to be SDR receiver. Basically, everything that pumps bit stream into the system could be a source. So you can pre-record your right? You don't have to do this in real time. Like you can just record the signal from your SDR and replay it at a later time. So you can use a file sync, sorry, a file source. You can also have a network source. Well, let's say you are having your SDR system installed in another location, or let's say a shed that you have in the backyard. And then you connect, you just stream all the data from your SDR to your shack at home using SDRangel. That's over the network. So now you're having a network source, right? It doesn't matter what is on the other side, as long as it can spit out bit streams that we can decode using channels. So that is the receiving side. And the same philosophy applies to the transmitter, the sync. That also makes sense, right? Because sync, you just pour everything into it. So you can have FM modulator, SSB modulator, and many other things all running at the same time, though not encouraged. And I don't feel like there's a reason you should do it unless you're, well, I don't know, doing something really new, experimental. I mean, then you can have multiple of these modulators turn on at the same time and write all the samples into a sync so that your SDR can transmit. And again, it doesn't have to be an SDR transmitter. It can be a file. It can be a, well, for instance, network node, a network sync, so that you're writing into the sync and somehow in the background another program is forwarding all your bit stream into your SDR at a shed or at a different location at your antenna farm, let's say. So that's pretty nice because of this configuration. SDRangel isn't really anything until you configure it to do the things you want to do. So it's highly versatile, but you have to learn how to. Just to give you an idea what the UI looks like, there are a bunch of configuration and parameters that it can set to fulfill your goal. System parameter and performance, you probably wonder how things actually works, how well things actually works, sorry. So here's a Pluto SDR. That is the original, sorry, the original module called Pluto SDR is I believe was created by Analog Device for their college program. So it's sold as education kit. It's not supposed to be highly sophisticated, like commercially sophisticated. It's just something for student fun. So don't really expect this will do something as great as commercially available like lab grade SDR, but it is very affordable because it was intended to use as education kit and so to students. So they are actually, well, at least in my opinion, they worth the price. And there are third parties doing the modification to the original Pluto SDR, which is called Pluto Plus. And I think they upgraded the reference clock to make it temperature compensated. They also add Ethernet port support, SD card, and a bunch of other things, just fancy features. Well, of course, for a much higher price, but again, just in my opinion, I think it worth buying. I'm willing to pay for the upgrade. So here's it. You have a little sock that is a FPGA that's running on the board doing mostly the digital signal processing. And also you have ADC and DAC for receiver and transmitter. The range looks pretty good because the expanded range there's no guarantee, right? Because according to the Analog Device, the original manufacturer, they claim the range is somewhere like 300 meg all the way to 2 gig or something, but it actually has much wider range that you can use, but there's no guarantee in the performance in those range. But it actually did well, I would say, fairly well. So 70 meg to 6 gig, that covers a whole lot of ham radio band. The reference clock, you can actually configure it, and you can have external clock input, but you have to do a little bit hacking because 40 megahertz reference clock isn't that easy to find on the market, especially if you want to do an upgrade with GPS-DO. Usually it's 10 megahertz output. I mean, go ahead, but you definitely have to modify the code in the kernel a little bit to tell that we are running on a 10 megahertz system. There are a lot of RAM, actually, plenty for a little. There's a Linux running on the board, so 512 megabyte is actually a lot on the board. That also tells you the fact that given there is a little trim Linux distribution that's running on board, you can technically run this without even plugging your PC. You can do a lot of processing simply by running your DSP program on board, which is cool. Yeah, connections, USB. As I said, it's a Linux computer inside, so you can use whatever device that supports OTG. And DC, just I think fairly reasonable, 502 amps. You can power it with whatever charger you have at home. Sorry about that. This is the RF chip that they have listed on Analog Device Wiki. A lot of specifications are missing. I don't know why they even have it there, but just in case if you wonder how well it looks. One thing I do want to mention is about noise figure. I copied this note from Analog Wiki, but basically when we talk about receiver sensitivity, it's actually the ability of the receiver to demodulate a signal, and it doesn't really make sense for pure radio. And in this case, SDR is a pure radio because if you don't have any demod channel attached to it in the SDRangel, it's simply, sensitivity doesn't make any sense because we're not demodded. So in this case, we talk about noise figure. The noise figure is supposed to be 2.5 dB at maximum RX gain, which looks pretty convincing. But in reality, I think it's probably the poor preamp that I'm using. So it's just not doing as great as it's supposed to be. I couldn't really hear the weak signal from distant stations. So that might be something I want to investigate for the next few months. I don't know, before the next June contest, so I can get it really set up by then. And Pluto SDR, given that it is fairly new and we don't have a lot of data available on the internet, I actually did some tests for TX power versus frequency. So you'll see that TX power drops at higher frequency and it just remained pretty sound through, well, let's say like sub 1 gig bands. But with that little LNA enabled, it gets a significant boost. So you will have steady 22 dBm output below 1 gigahertz, and at 5 gigahertz you still have like 5.5 dBm, which is weak, but still acceptable. So here's a plot, just let you visualize the data or the measurement that we had. Basically the cutoff starts, it starts to roll off above 1 gigahertz. But I will say in practice, even on 1 gig, 2, 3, all the way up to 3 gigs are pretty easy single sideband content that we made on the system. On 5 gig, sometimes it's just too weak, so we sort of have to do this in CW. It's a shame, but we still made the most of it. Here's a QST report. Given that in the contest, we didn't really talk about the precise dBs anymore, we will just assume that if it's possible, we will do single sideband first, because it's a lot easier to change the information. Otherwise, we'll do a CW, or we'll put a 0 mark here if that's too weak to make any contact, or busy the other stations. Do not want to talk to me. That happens sometimes because they are pretty busy. W2XZ actually sort of dominates the game because we have many people and we are sort of well coordinated, and there are a bunch of experienced ham operator there. So they are really busy during the contest too. So sorry. Just a bit more analysis. If you look at FN, except FN34, which is like 100 miles away, and except 5 gig, that's above 50 miles, most of it, for most part of the contest, we did it using a single sideband. It was very clear and easy contact, using only 100 milliwatt, and actually less than 100 milliwatt on higher bands on 1, 2, and 3 gig. So think about that. Here, just a sample field testing memo. We did a lot of testing during the summer in the lab and in the field, and well, that was a lot of work. But this is a sample of testing memo that we did. We tried FT8. It was working fine. This particular site is 132 miles from the testing site. From the main station, and we are still able to make contact using FT8 and digital mode. So you should never underestimate the power of QRP. Even on a higher frequency, it's not just HF. So really, it's a game changer. I think, yeah, this is the last slide. I think this is really a game changer, given that I never ever thought about how far 100 milliwatt can bring you, or 200 milliwatt. 132 miles, that's very impressive. Even above 100 miles, it's totally feasible. If that's just 50 miles, it's very, very clear and easy single sideband contact. It's probably using the setup like this under $500, you can do something great, and I will call it the next generation of the contesting kit for rovers. Questions, Q&A. I think we still have 20 minutes, so that should be plenty of time.
Well, down your desktop.
Desktop?
Yeah, your presentation. If you're done with that, click up to the top. You can close that out.
Oh yeah, no problem. I was just doing like Q&A session. That was actually the last slide, so it's frozen there.
Okay.
Yeah. If
you close that out, then close your sharing out, then you get to see more going on.
Oh yeah, sure.
Okay, looking good.
Oh, hi.
Okay, and we got you sharing, and we're gonna. Okay, do we have any questions out there?
Oh, is it hard to learn to use the software? You mean SDRangel, right? It's a bit, well, you have tutorial, so it's really just following it, and wouldn't say it's terribly hard. But given that it is a completely different design from traditional SDR programs, I would say yes, it might take a while to learn. You will love it if you're a programmer, because this thing is highly abstract and everything's in order. At least I would say I like it. Yes. It's not terribly hard. It's very logical. It's just a very different logic than what we are used to.
Okay, Dennis, you got your hand up. Go ahead and take it.
Yeah, Hisen, this is great. Nice project. I'm impressed by what you've done here. I wanted to ask you if you were just talking about the software. Is your software available on something like GitHub or anything
Yes,
like that?
it is. I don't know if I should share my screen again. Let me put it up.
I did see you did have a link to GitHub but I thought that was for the Pluto SDR or something for that.
Right,
But
that was for Pluto SDR. But yes, SDRangel, you can actually look it up. And
oh, okay.
that's probably much easier. But I have okay, SDRangel README. I'll share the wiki page of
Okay.
SDRangel. Well, what about Quick Start? Yes, even better. Um,
Yeah, this is very cool. We've got a bunch of guys out here that of course, do VHF and the VHF and microwave contests. I've done a lot of microwave contesting, and I agree with you about the bulkiness of the sets that you take out on the road. I got a kick out of the rack. What was that? W2AAU's rack in the back of the vehicle. Yeah, that looks very familiar. so
yeah,
so reducing that down to a small package is fabulous. And I don't think one of the guys that I was hoping would be here tonight, and he's been really sick, but somebody who needs to see this is one of our guys down here in Southern California, is Marty Wall, N6VI, who's a member of our RATPAC planning team, and he's a very active VHF contest rover, and he's done a couple of presentations on roving, or on here at least one on VHF and UHF contesting and roving that he did, and showed off his equipment. And it's compact, but it's not that compact. So you've done a great job of reducing the footprint of a package there. That's really nice.
It looked to me like he had multiple, what do you call it, things he was trying to accomplish to get it all done. There was several things: the size of the package, what it will do, and how it does it. He had several things going there.
and yes, and this is definitely not the most compact design because everything is on the flat board. We can definitely do some arrangement in 3D space, and well, let's say put that in the project box, and that will make it even more compact, and it's totally feasible.
Okay, got another question in chat.
Oh, have you thought about less expensive? Okay, Hack RF1. Um, I never tried Hack RF1. I know it's a good SDR, and it was one of the earliest available on the market, I believe. But I think the ADC or DAC that are used is only 8-bit, and this Pluto SDR is using 12-bit. And I think most of the SDR that's coming in recent year, I would say last 3 or 4 years, 3 years maybe, are mostly 12 bits. Sometimes you can get 16 bits for DSC or ADC. And remember, each extra bit will give you about 3 dB or 3 dB or 6 dB improvement. I have to look it up, but yes, there's a constant, like the more bits you get, the better signal to noise ratio that you have.
You know, Dave is agreeing with you. Instead of an SBE, that it's 8 bits. There's another question, and look like our shirts. The question is not going to be in chat. Do you build your own filters?
Filters? No, actually, filters are I'll say the most ugly part of the project, sort of, because I'm using the lab filters. They are really good filters, but they are sort of bulky. Well, not that bulky. I mean, especially on higher frequencies. 144 will be a bit, that's a big tank. I'm using a cavity filter. But given that we were just doing testing, it might be possible that we can replace them with Helix or other smaller, more compact filters. The ones that I use on HTs. They're pretty much, there are a lot of surplus actually on 144 and 432. On other frequencies, you probably want to I don't know, look for other filters and try to tune them I was looking into SAW filters too, but they are usually very low power. I mean, very low, and usually less than 100 milliwatts. Um, and given that on most of the band, or at least on the lower portion of the band, I can do 200 milliwatts as 22 dBm. SAW is probably not the best fit in this case, right? On a higher frequency, I believe the cap filter, the one designed by I forgot his call sign, GHC, W2GHC, was it? Yes.
Yeah, it's called W1GHC, the pipe cap.
W1GHC, yes.
Yeah. Mm-hmm.
Yeah, and they are very calm design and on microwave bands too. And you can probably try that, and you can make yourself pretty compact filters and easy to tune. We're just running out of time by this. I mean, I start. It's like in June contest. I figured that there's a feasibility we can do this, and over the summer I have to order the parts. I did a lot of lab and other testing. I just want to make sure that the entire system works. First of all, filters are something extra, the bonus we can do it, and definitely given that to the next. We still have like 6 months till the next context. So there's plenty of time that we can work on the filters and improve system. We also have other team scheduling issues, and because if we are doing this low power, it's a whole different strategy than high power roving. And that's something that we should, I mean, at least W2SZ should research as a team, like how to improve the efficiency.
What to you is high power?
Rover does not, well, like officially they do not distinguish high power from low power, but I will say anything above 1 watt or let's say 10 watts. I think they are really high power rovers.
Okay.
Regular power rovers, I would say. I'm just being extra low. But I think that's the future too, because think about your mobile phone and other devices. Most of commercial products actually communicate on a very low power level. That is limited in the range, but we can probably make it better and try to do like 100 milliwatts over 132 miles. It's totally possible.
Well, one thing about that frequency, you get a lot of gain in your antenna.
That is, we are using the dish here, right? The other side of the testing station that we have in, I believe, they're using 6-foot dish. Well, because they're on tower anyway, right? And I think that's fairly common in the radio contest. I'm just using this 2 feet dish, which is actually actually a lot of gain. But the most important thing is that you do survey the place so that you make sure there's a line of sight or nearly a line of sight, because the curvature of Earth, you couldn't really have a true line of sight. Sometimes there's just a tree that's growing in the middle and you never know because you couldn't visually see it over 100 miles.
Oh, come on now. You got to change your glasses.
Yeah. Yes. So it's also important to choose the right location, and perhaps do some simulation. There are a lot of calculators online that you can do. Sometimes they also ask for humidity because they're like pretty. They do have very good models for something, let's say less than 24 gig, because I remember W2AU told me there's no good model for like above 24 gig. So it's really just great, like bonus. If you can do that, that's 4 credits per site. But if you couldn't do it, that would be totally waste of time. But 10 gig, you can still do it. And especially with this setup, use like all the way up to 5.7 gig the 6 gig, it is still reasonable and can be well modeled. And if you do want to take humidity or ring scatter into account, yes, there are good models that you can use to do prediction.
It sounds like a lot of fun work.
Yes, in both theory and application, like to implement this system.
Okay, are there any more questions out there? I don't see hands up. What's going on in text?
I would really like to, sorry.
Oh, go ahead.
I would really like to like pass this around because that's what I pass the setup around because that's what I usually do in a local meeting, but unfortunately we couldn't. You know, just really pass around and let everybody have a closer look in their hand. But we couldn't do it in this case, and also it's currently in my car now, so.
When we're all done with this presentation, could you please send me your slides?
Oh yeah, of course.
Okay.
Of course. And probably I'm gonna put in extra links. Well, like the SDRangel and other stuff here.
That would be very nice.
Yes, I'll put that in the reference section. So anybody's interested in that, just dive into the very last slide. And you should be able to find the most useful link here.
All right.
Include the calculator too.
Well, Barry, are you out there?
I'm here.
Okay, I just now saw you there. I've been doing the text thing myself, so I'll turn it over to you there. We usually have a tag team here. One takes care of the text stuff, the other takes care of the other stuff. Barry's out there, has been here forever. Everybody knows him, and he takes care of the text. Okay, I'm looking for some more questions. Great presentation.
Thank you.
Okay, Dennis, you got your hand up?
Yeah, I got my hand up. I got another question. Yeah, the way you illustrate that 2 meters through 5760, you show you're using the log periodic feed with a 2-foot dish. Well, that's not going to work very well down on 2 meters or even 220, probably not even 432. So what are you using for antennas for the lower bands, like below, let's say like 1.2 gigs?
So this log periodic actually works from 800. Well, that's what the seller says. I just bought it in AliExpress anyway. They claim it to work from 800 meg to 6 gig. So if it just fits most of the band that we're using. For lower bands, I'm actually when I'm doing the testing, I use simple dipole that's made of coax cable. Believe it or not, it's really just like there's no common mode current suppression. It's really just a BNC cable that I just strip it in the very end because I just don't have Yagi on both bands anyway. So that's the best I can do for testing. In the contest, I figured it's just a lot easier if I'm using my car radio antenna, put it sideways because the polarization, right? It's usually the car ones are vertically polarized, but yes, the one that we use on the main station are horizontally polarized. So what I do is instead of sticking that on top of the car, I stick it on the side.
Interesting.
And it just do things well.
You could try like horizontal loop. The little those are pretty compact for a lot of rovers use all the way from 6 meters up to 432. The little loop antennas, they're very compact. Companies like M Squared make those. It's going to raise the cost, of course, but you could probably do a DIY version of the loop antennas, square loop.
Right, and I believe, yes. So excuse me.
No, go ahead, Hisen.
Sorry. I just feel like yes, that's definitely doable. And I'm thinking that if we are able to do this at low power just with car antenna,
Yeah.
we probably don't even have to worry about it because
That's
yeah,
pretty
I mean
amazing.
we made it. We made it. And it's proven to work.
That is really amazing that you've made those distances or those powers with that kind of antenna. That's pretty
Yeah.
cool.
It's a
Yeah.
dual it's like a little dual band car antenna anyway.
Well, I'm going to suggest everybody take a look at the chat there. There's some interesting comments and some humongous links. David, KF7 DOJ just stuck half a page of it.
Yeah. Oh, that I think that's exactly the same. Oh, it's much cheaper now. I don't know if there's a promo or anything. Oh, new user bonus. Anyway, it's not applied to me. So 50. Yeah.
All right, I don't see any more hands.
Thanks for the idea. I think I missed them. I happen to have a hack RF1 laying in. Oh, you can definitely start off trying this. Especially in shorter range, and especially if the other station has very strong signal, so you don't really have to worry about SNR. Because when we talk about signal, it's always relative to noise. If you have high noise, or if you have low noise, you have high power, then that's a guaranteed copy. Generally, yes.
Okay. Barry, you see anything I'm missing?
No, we're all up to date.
Okay.
Yeah.
Well, it's good. Just about at the hour. That's pretty close timing there. Been a
Very
great.
good timing, actually. I spent exactly like 40 minutes on the presentation part, and then we had an extra 20 minutes on this Q&A session. It's just perfect.
It is. It was a great presentation. It, I have to comment, as I do every time on these things. We have our Zoom license allows us to do up to 500 presentations, or have participants up to 500. And in the beginning, during the cohort, we used to meet or exceed that every once in a while. And since everybody's been freed up from all the COVID thing and gotten back to their life, it's gone down. However, what we do, all the stuff showing up on YouTube and other media is gone sky high. Lots and lots of hits and people watching this stuff. So your presentation will be certainly appreciated by a lot of people who's going to view it.
Thank you, appreciate that. And the reason I'm doing a lot of presentation, either at my local club or doing this QSO today, or in this case just a Zoom meeting, is that I want to share my minds, because usually I am inspired by other great minds too. A lot of people share their idea on the internet, usually in the form of blogs, or sometimes they create videos. I mean I can make videos, but I'm just too lazy to, because I'm busy with other things too, and video making.
You got enough on your plate.
Right. So but I also feel like it might be better if we can do like in-person communication. It's not really in person in this case, but it's like talking, and you can get immediate feedback from the author of the project owner, and that is awesome.
Well, that's why we do this kind of presentations, really doing the webinar, that kind of stuff. It gives us an opportunity for the audience to make their comments, ask their questions, and get directly involved. It just gives a lot more to it.
And it's also good for the project maker, the one who's in charge of the project, because we can give feedback instantaneously too. So that's a very good opportunity. I really thanks RATPAC for inviting me to this event. Probably we can do more in the future. I mean, remember that simple digital protocol for HT. Like you can literally transmit any arbitrary files on the HT by dialing on the keypad, or let the computer dial for you. Yeah.
Well, I think we have Dennis to thank for this one here. Dennis, you got your hand up. Take it away.
I sure do. It just occurred to me. Hisen, first of all, thank you so much. This was a great presentation, and it's a two-way street. You're very inspiring with what you're doing in your projects, and this is very cool. And what I want to recommend for you, I don't know if you're familiar with it or not, but we have an annual conference called Microwave Update.
Oh, I definitely know that.
Yeah, it's going to be close to you this coming year, and I think I'm just checking out the date on it. It's in April, and it's in Connecticut. So I would urge you look for Microwave Update 2023, and submit a paper for the conference. This would be a great topic for that conference, and I think people would get a real kick out of seeing this.
Yes, and I actually, because I'm really into this ham radio community starting my freshman year, and the time that I really get into the community and establish my ties were basically like beginning of this year, 2022. So I definitely heard about Microwave Update, but well, they're a very interesting group anyway. I think they was there a delay? I think they were supposed to hold the update like early.
Yeah, it's been postponed because of the COVID pandemic.
Unfortunately,
but, what we do is Microwave Updates gets rotated around the country, and tends to be back in the same city every 5 years or so, in the same area every 5 years. The same club sponsors it. So we've sponsored it out here several times here in Southern California. It's been sponsored up in the Bay Area by the Microwave group up there. And this one, I'm not sure this is. Oh, they're adding even better. I'm just reading their notes here. It's the VHF UHF conference is going to be combined with the Microwave Update. We've done that once before out here, but that's cool. Even better still for you to show this there. So
yes, that's a great opportunity. And I think by then, this is April 14 to 15. I think I can make the system much better. Especially I think that's the amplifier issue with it. That's why the noise figure isn't really up to the spec. But hopefully by then we can fix it and make the system better.
Yeah, that's right. It is the Northeast Weak Signal Group. That's who's sponsoring it. Northeast Weak Signal Group. So Paul Wade is one of the sponsors.
Yeah, I've been there sometime, and W2AAU, Richard is a member there, and definitely that's how I know that group. He showed me there.
Okay, super.
Yeah.
Well, go for it. And I personally look for a lot more from you, interesting stuff from you in the future like this. This is really cool. So really glad that we were able to meet up with QSO today and able to get you here on RATPAC. So this has been a great presentation. Thank you so much.
It has. It really has. I really appreciate it, Dennis. I appreciate you bringing him on board. Dennis is one of our RATPAC planning committee members, and he's a great contributor to the presentations like this. It's got he knows the right people.
I appreciate that, Dan.
Look for talents.
Look for talent. Exactly right. That's it.
All right. Well, unless there's some more questions, whatever, I will wrap this up, and you get a chance, send me the slides, and we'll go from there. Get this stuff out there.